Let us calculate what is energy stored in an inductor. This is also very important topic. This is similar to energy stored in a capacitor. Imagine one inductor is here and we have applied potential difference V, or we have connected battery across this inductor. Because of that, current I is flowing through it. This is at any instant current is flowing through the inductor. Now, when current is flowing through the inductor, the induced EMF produced, EI is equal to minus L di by dt. This one we know. Now, this is induced EMF. Now, when we want to send charge or current through it, obviously our potential difference must be equal and opposite to this induced EMF. Hence, applied EMF, E applied is equal to minus E induced, or that is equal to L di by dt. Now, this is applied potential difference at any instant because current will gradually increase. Now, if we want to send few amount of charge, suppose dq amount of charge we want to send further through this inductor, extra charge, then obviously we have to do some work. Hence, what is the work? Work dw is equal to, we know, work done W equal to Q into V, or charge times the potential difference. Now, potential difference applied is EA. Hence, work done dW equal to dQ, charge time potential difference is L di by dt. Now, if I will rewrite it again, this portion, if I will rewrite, then I can write L di by dt into dq. Again, if I will take dt this side, then I can write L into dq by dt into di. Now, what is dq by dt? dq by dt is the rate of flow of charge, extra charge that we want to flow through the inductor. And so dq by dt is current. dq by dt is current at that instant. Therefore, if I will rewrite it, then what is dw? dw equal to L into I into di. Now, this is a small work done when we want to send dq amount of charge through the inductor. But as current gradually increases from 0 to maximum level, certain amount of charge might have passed because of this total current. Hence, what is the total work done? Now, total work done, W, is equal to integration of this dW starting from 0 to W, or that is equal to what? Integration of L I di, limit is from 0 to maximum current is suppose I0, or that is equal to L is the self-induction, L will come out of this integration, hence L integration of I di, limit is from 0 to I, or that is equal to this I0, maximum current is I0. Therefore, L into integration of I di is I square by 2. Limit is from 0 to I0. Okay. 0 to I0. Therefore, what is the total work done? Or this is equal to L into I0 square by 2 minus 0, or that is equal to half L I0 square. Therefore, this work, total work done when the current increases from 0 to I0 is half L I0 square. Now, this is the work done. And this work is stored as energy inside the conductor. Okay, therefore, energy stored in the inductor U equal to half L I0 square. Now, let us see in what form this energy is stored. We know coefficient of self-induction L is equal to mu 0 n square by L into A. Mu 0 n square by L whole into A. Now this is coefficient of self-induction. Again, we know magnetic field B is equal to mu 0 into N into I, magnetic field inside a solenoid, or I can write this is mu 0 N by L whole into I. Now, if the maximum current is I0, then I can write mu 0 N I0 or mu 0 N by L I0. Therefore, what is I0? I0 is equal to mu 0 N by L. I0 equal to, sorry, this is to be removed. I0 equal to, I0 is equal to B into L divided by mu 0 into L. Now let me put the value of L and I0 here. Therefore, total energy U equal to half L is mu 0 N square by L into A into I0 square, that is B square L square by mu 0 square N square. Now N square cancelled, L cancelled, mu 0 cancelled, hence what is left? That is U is equal to half into, you see, B square A into L, B square A into L divided by mu 0. Now, this is the energy stored inside the inductor. Now, if this is the energy stored inside the inductor, then what is the energy density? Energy density, just we had already calculated in case of capacitor, energy density is equal to energy stored by volume, or the energy stored is what? Half B square by mu 0 A into L divided by volume is area into length cancelled, or that is equal to B square by 2 mu 0. Therefore, energy density is equal to B square by 2 mu 0. Now, this is similar to the energy density of capacitor. What is that? Half epsilon 0 E square, energy density in case of capacitor. Hence, if we compare these two, in case of capacitor, energy stored in form of electric field between the plates, and in case of inductor, energy stored in form of magnetic field is in the inductor. That's all.